All right, so the last thing we talked about was the inflection point. And now we're going to learn how to apply the second derivative test. We've also talked about the first derivative test, and that was like 2 weeks ago. Now today we're going to talk about the second derivative. Now, if you have a function f where f prime of c is equal to 0, right? Meaning this c is a critical point, and the critical point is evaluated at the first derivative, right? So if you assume that you have a critical point, now there are three things that can happen. If you evaluate the second derivative at that critical point, and it gives you value that's more than 0, which is positive, then what you have is a relative max, a relative mean, because the function is concave up. So the function is concave up. So you have a relative max minimum. I don't know why I keep saying max. I guess I like the word max. You have a relative minimum at c, right? And conversely, if f second of c, meaning if you evaluate the function, the second derivative at that given point c, and if it's less than 0, which means if it's negative, then the function is concave down, and what you have is a relative max this time. So you have a relative max. So this is case number 2. Now, what if you evaluate the second derivative and the second derivative gives you 0 at the critical point? The test failed, it's inconclusive. So you may have a max or you may have a mean, but the test fails. You cannot use that to prove whether the function has a maximum or a minimum. So what you do is you use the first derivative test. So the concavity is basically when the second derivative is positive, right? You have a concavity that's going up, which means the function is doing this. So the function has a relative minimum, and then when the concavity is down, which means when the second derivative is negative, then the function is going down, you have a relative max. So I worked on the problem earlier, and I have that on the board for you. So assume you have a function f of x equals negative 3x to the 5 plus 5x cubed. Now you want to apply the second derivative test. So what you do is this. The first thing you want to do is find your first derivative, because to get to the second derivative, we need to find the first derivative, right? So our first derivative is negative 15x to the 4th plus 15x squared. Then we find the critical point, right? The critical point by setting the first derivative to 0. And our first derivative, when you set it to 0, you're going to get negative 15x squared, parenthesis x squared minus 1. Apply your algebra 2 knowledge to factor function. And then you have 3 critical numbers. You have x is 0, you have x is positive 1, and you also have x is equal to negative 1. Now, what do you do with this critical point? So you create a table to apply the second derivative, right? So our first critical point was 0, the second one was negative 1, and the other one was positive 1. So to find the y coordinate of those critical points, you need to take them and plug them back into the original function, okay? So when x is 0, obviously, if you f of 0 gives you 0. And then when x is negative 1, f of negative 1 gives you negative 2. And when x is 1, f of 1 gives you positive 2. Now what you do is this. You're going to evaluate this point and then plug them back into the second derivative to see whether they're negative, positive, or 0. That's going to help us find the relative max, relative mean, or the test fails, right? Now in this case, when you plug in 0 here, you get a 0. So the test is inconclusive, it fails for the first one. Second one, when you plug in x to negative 1 in the second derivative, you get positive 30, which is more than 0. That means you have a relative minimum according to the second derivative test, because the function is concave up. The last one, when x is 1, we get negative 30 for the second derivative, which is less than 0. So you have a relative max because the function is concave down. So basically that concludes our little lesson on applying the second derivative test. Okay, there's more problems you can work on. So all you need to know is this. You need to find the first derivative, find the critical point, and use those points. And you find the critical point, and then you find your second derivative, and you plug in those points into the second derivative to see whether they're positive, negative, or 0. When they're positive, the function is concave up, you have a relative max, and when they're negative, the function is concave down, you have a relative mean. And when it's 0, it's inconclusive, you have to apply the first derivative to find whether you have a maximum or a minimum. All right, have a wonderful day, and I'll see you next time.